An interrupt pin is a digital input that can execute part of the code only when it receives the signal from the pin. But the difference between this and a normal digital read is that the interrupt stops the processor from whatever it's doing and executes the section of the code we want, and after that the processor continues running everything from where it was left. This is important in cases where it's critical to not wait for the loop to execute something. As we know, the loop executes the codes over and over, usually very fast, but sometimes we want to register changes in the input that can happen too quickly, much faster than the loop. These are the cases where we use an interrupt. In this example, I use an interrupt to create a tachometer that, even though it refreshes the display only once per cycle of the loop, it can still count each of the pulses of the sensor, which happens a lot faster than the loop, to be able to calculate the revolutions per minute. Keep in mind that only a few pins in the Arduino board have the interrupt option. In the Arduino UNO and Arduino Nano, only the pins 2 and 3 can be configured as interrupts. We can do that in the setup with this line. Selecting the pin we want to use, the name of the section of the code we want to run when the interrupt is triggered, and then the type of trigger. For this case, we use falling, meaning that it's going to trigger when the pin goes from high to low. But there are other options. Over here we have an LED blinking running in the normal loop, but we have a section that is going to execute when the interrupt goes from high to low, turning the LED on. This section is outside the loop, so it's only going to run when we trigger the interrupt. The LED is blinking on each loop cycle, so without the interrupt, it will have to wait for the loop to execute the code to read the input. But with the interrupt, it executes that immediately, no matter what. One thing to consider when using interrupts is that since we are giving priority to run the code triggered by the interrupt, we should put as little code as possible to not slow down Arduino too much, because that could interfere with other things that Arduino was doing before the interrupt was triggered. The shield has a few connectors where we can connect more devices like ultrasonic distance sensor, MP3 player, real-time clock, and a lot more. That way you can expand the possibilities of this shield. But at some point you might want to make your own circuits. The next step is to use an Arduino Nano with a breadboard and jumper wires, which allows more freedom with the trade-off that is a little more complicated. The learning process never ends, so keep experimenting and trying new things. I'm sure you're going to be surprised at the things that you can accomplish with Arduino, and you never know where that knowledge can take you. I hope it was helpful and see you in the next video. Bye bye.